Hi, my name is John.
And my name is Alice, and we're Math Videos for Parents. We help you so you can help your child with math. Today's topic is prime factorization. And so I'm going to answer the question, find the prime factorization of 36 using factor trees, which is a really fun technique that I had learned. So what I do is I'm going to write the number down, 36, and then I'm going to ask myself, what two numbers could I multiply to get 36? So you have different options here. You could put down 6 times 6. That would be correct. What I notice about 36, though, is it's divisible by 3. And the way you can check that is if you add up the digits of the number, 3 plus 6, that equals 9. 9 is divisible by 3. So I know I can put a 3 here, and it's going to go in cleanly. So 3 times 12 is 36. Okay, great. Now, 3 is a prime number. So the reason I know that is you can either just memorize the prime numbers under 10 are 2, 3, 5, and 7. Or you could ask yourself, are there any two numbers I can multiply to get 3 besides 1 and the number itself? And in this case, there isn't. The only way I could get 3 by multiplying two numbers is to multiply 1 and 3. So because this is a prime number, this branch ends here. 12, though, I can multiply by, say, 6 and 2. Again, you have a few options. I could have done 4 times 3 there. 6 times 2 is 12. So now I'm going to focus on 6. Two numbers I can multiply to get 6 are 3 and 2. And again, 3 is a prime number, so I can't keep going. 2 is a prime number, so I can't keep going. Let me check this branch. 2 is a prime number, so I cannot keep going. So the prime factorization is the prime numbers at the end of all these branches of the factor tree. So it's going to be 3 times 3 times 2 times 2. And the nice thing about math is that you can often check your work and you can confirm you're right, or if you know you're wrong, that's fine. You can go back and redo things. So you can take out your cell phone or calculator and do 3 times 3 times 2 times 2 and confirm you do get 36. So John, that's factor trees. How would we approach this problem with repeated division?
So the good news is repeated division sounds like something very, very scary, but it's very similar to what you did with factor trees. The idea is we want to keep dividing 36 down into smaller and smaller numbers. And when we divide, we want to divide by a prime number so that we can keep track of the prime numbers that go into 36 or are factors of 36. So we will perform it in a repeat type fashion. I noticed that you started with 3 and 12. Just to show that there are multiple ways to arrive at a correct answer, I'm going to start by dividing by 2. This might be easier for some students who don't know the digit trick with adding up 6 and 3, the sum being 9, and that 3 goes in. They might see 36 as an even number, and they know that all even numbers are divisible by 2. So just something different to think about. And we know that 36 divided by 2 is 18, which is also an even number, so I can divide by 2 again. That gives me out 9. And 2 doesn't go into 9 evenly, so I would like to use a different prime number that goes into 9. Given the very few options available, I'm going to go and use 3. And 3 goes into 9 3 times. So when all is said and done, I have the following numbers that go in. I divided 36 by 2, then 2 again, then by 3, and I'm left with the prime number itself. I could divide by 3 again and get 1, but 1 isn't going to affect my my result, and 1 isn't a prime number. So my final result is 2 times 2 times 3 times 3, which is also 36. So either of these representations would be considered a prime factorization of 36.
Great, thank you, John. So I think the two things I'm going to have to keep in mind with this technique is that you only want to divide by prime numbers. And also the answer is going to be an L shape. I'm going to have to remember to grab that number kind of at the bottom of the L. I think with factor trees, I'm kind of used to looking linearly. So those are two things I'm going to keep in mind, and I'm going to tackle a problem next.
Great, go.
Okay, so now I'm going to use repeated division to find the prime factorization of 270. So I'm going to write the number down. And I want to put a prime number here. So I'm going to put 2. It's an even number. I know 2 will go in. Okay, so now a prime number that goes into 135 is 5. Repeated division, just like the name. Just keep dividing. And then 3 goes into 9 3 times. And now 3 is a prime number. The only 2 numbers that go into 3 are 1 and 3, so I know I can stop here. And so what I'm going to do now is I need to grab my L numbers. And I'm going to say, okay, for such a big number, it broke down fairly quickly. I'm going to say 270. The prime factorization is 2 times 5 times 3 times 3 times 3. And I'm going to check just to make sure. Again, with a calculator or a cell phone, 2 times 5 times 3 times 3 times 3 does give me 270. So that looks like a really good approach, John. I can see how it just breaks it out nice and cleanly at the end there.
Now, if I would have started with 5 instead of 2 first, would that affect my outcome?
Well, I would think you'd get the same answer at the end. You might have gotten there quicker because you divided by a larger number to begin with.
Great. So, in even 3, any of these numbers in the list would have been okay if we started with any of them. So,
in fact, let me do that real quick. Let me do 5 first. How does that sound?
Yeah, that would be great.
And that's also another good way to check your work, is to do it 2 different ways and make sure you get the same answer. It's kind of like when you move to a new neighborhood, you really know your way when you can go 2 different ways to get somewhere. So let's see, 27 is divisible by 5 times. 54. 54 is an even number, so I'm going to say it's divisible by 2. 27 is divisible by 3. And 9 is divisible by 3. So I'm running out of room there, but you can see I do get the same answer. 5 times 2 times 3 times 3 times 3 equals 270.
Great. So this was a very worthwhile back and forth about prime factorization, which gives you different ways to understand it and work with it, and also gives you an idea as to effective mathematical practices like checking your work, providing multiple pathways to get the same answer, and just making sense out of what you're doing. So thank you very much for joining us. We are Math Videos for Parents, and we hope to see you again soon.
Thanks for watching.